Hey Codersaurs, my name's Dr. J, and today we're going to be talking about the twists and turns that our favorite dinosaur can do, and how we measure and describe those turns using things called angles and degrees. So the first thing you need to do is fire up the Codersaurs GUI. As usual, it starts up with a blank screen and the basic commands on the right hand side. However, we've moved on from the basics, so you're going to want to click on the intermediate commands button. It's the middle button at the top of the screen. When you click on it, your screen should look like this. The first thing you'll notice is a large blue circle has appeared underneath our dinosaur. The second thing you'll notice is our buttons have turned from being nice tidy arrows into weird symbols and numbers. You can ignore those for now, we'll get to them later. But for now, let's have a closer look at our blue circle. The most important thing about this blue circle is the numbers going around the edge of the circle. You'll notice on the outside, the numbers are going up in multiples of 10 all the way around in a clockwise direction to 360. Clockwise means moving in the direction the hands of a clock would move. Similarly, if you look at the second row of numbers, or the inner track of numbers, they count upwards in multiples of 10 in an anti-clockwise direction. Now, 360 looks like a very strange number to count up to. What's special about this number? Why don't we use something more familiar, like 10 or 100? Well, that's an interesting story, and it dates back 4,000 years. But it's a story worth telling. Now, thousands of years ago, there weren't things such as calculators and computers, but there were some pretty impressive civilizations that ruled supreme. One of them was named Babylon, once the largest city in the world, and famous for its beautiful hanging gardens. But they were also famous for their agriculture and trade, and things like agriculture and trade need numbers to keep track of what's going on. How much have you bought? How much have you sold? How much have you produced? How much do you need to plant? All these kinds of things required numbers. Now, 4,000 years ago, numbers were quite a recent invention. They hadn't even discovered the number 0, for that matter. But what they did notice looking around them were some fairly strange phenomena. One thing the ancient scholars noticed is that the seasons seemed to keep repeating every 360 days, what we'd call a year. They also noticed that the full moon appeared roughly every 30 days, 12 times a year. It was also easy to count up to 60 using the thumb and the 12 bones on your left hand fingers, and using the 5 fingers on the right hand side to count out how many times you counted to 12 using your thumb. 12 times 5 is 60. To the Babylonians, numbers like 12, 30, 60 and 360 were quite mystical numbers. They had magical properties to them. They even had symbols for some of the strangest numbers you could imagine, 10, 60, 600, 3,600 and so on. But perhaps the most interesting thing about the number 360 is it has a very peculiar ability to be divided up equally into so many different ways. So imagine in the days long before computers and calculators, and long before nimble number systems like our decimal number system had been invented, how difficult it must have been to do division in your head. Well, the Babylonians devised a way that even the most humble shepherd would be able to equally divide up his sheep in a field, or a farmer would be able to equally measure out his bag of wheat. They chose to use the number 360 as a base for their farming and commerce because you can divide the number 360 in 24 different ways. If you start with 360 objects and divide it in 2, you'll each have 180 of them. If you divide it in 3, you'll have 120 of them. Heck, if you divide it in 15, you'll be left with 24 each. You can just divide 360 in so many versatile ways. The number 100, which we seem to use a lot in our decimal system, can only be divided into 9 different ways. Pretty useless in comparison. You can't even divide it by 3 roundly. So clearly these Babylonians had stumbled upon a very useful set of numbers. No wonder they're all over the place. Even 4,000 years later, there are 12 rolls in a dozen. There are 12 hours on a face of a clock. There are 60 seconds in a minute, There are 60 minutes in an hour. There are 30 days in a month. There are 180 degrees in latitude and longitude. There are almost 360 days in a year. And there are 360 degrees in a complete circle. Hang on, did I just say 360 degrees in a circle? Well, that brings us all the way around to our dinosaur and his little blue circle. So, it turns out there are 360 degrees around the circumference of a circle, and now that we know we can divide 360 into so many different ways, we're really going to take advantage of that. Remember in our last episode, we could do turns to the left and right, either a full turn to the right and left, or a half turn to the right and left. Well, look at our circle. If we do a full turn to the right, we see 90 degrees over there. If we do a full turn to the left, we see on the second row of numbers 90 degrees over there. And what do we see at the half turn? Well, 45 degrees, and 45 is exactly half of 90. 90 divided by 2 is 45. You'll also remember from last week that if we turn right once and then turn right again, we'd then be facing backwards. Well, what is 90 degrees plus 90 degrees? 90 plus 90 equals 180. And if you look around our circle now, notice the dinosaur is pointing downwards. He's always pointing at 0. If you look at 180 degrees from him, well, you'll see that that's exactly behind him. So if we turn 180 degrees, we're going to be facing backwards. What happens if we turn right another 90 degrees? So we've turned right 3 times. 90 plus 90 plus 90 is 270. That's the equivalent of facing left. So turning right 3 times 90 is the same as turning left once times 90. And finally, turning right another 90 degrees, the 4th time, we've turned around full circle and we're facing back to the top again. 4 times 90 is 360. 360 degrees is the number of degrees in a circle, and also 360 degrees brings us back to where we started, so 360 degrees is identical to 0 degrees. If you want to think out the box a little, what do you think 370 degrees is similar to? Or how about 450 degrees? What do you think that's equal to? Once you've thought about that for a second, I want you to do the entire process again, except this time in the anti-clockwise direction. What happens when we turn left 90 degrees, and we do it again a second time, a third time, and a 4th time. So this brings us back to the buttons on our Codersaurs intermediate control panel. These used to be arrows. Now they've become these strange symbols with numbers. But actually some of them are not so strange anymore. LT, left turn, RT, right turn, and 45 degrees, 90 degrees. We know 45 is half a turn, 90 is a full turn. So all they've been replaced with is turn left 90 degrees, turn left 45 degrees, or turn right 90 degrees, turn right 45 degrees. And if you switch back between the two, you can see the arrows have simply been replaced with their programming counterpart, so you can start describing them with words now. So now that we've covered the turns, all that's left are these FD and BK buttons. Well, FD is quite simply forward, FD for forward, and BK is backward. And the number in brackets this time is centimeters. So this top button here is moving forward 10 centimeters. The second button is moving forward 5 centimeters, and this third button is moving back 5 centimeters. So that's it for today. We've covered a lot of geometry of the circle, 360 degrees in a circle, and why 360 degrees is such a useful number. There isn't much more to do in the Codersaurs GUI this week other than get yourselves familiar with these commands, LT, RT, BK, and FD, and what they actually mean. So perhaps you'd like to try recreate this picture using just forwards, backwards, turn right 45, turn left 45. Can you see how 3-dimensional pictures are starting to come out of simple 2-dimensional drawings? So, until next time, this is Dr. J, signing out. Ciao.